Hello everyone. I am visible not. I am visible not. Okay, so voice is clear. Think I am not add the thumbnail, lecture thumbnail. So wait for 2 minutes. Okay. So now I am continue the lecture. So hello everyone. Myself Divyanshu Srivastava. Today I am going to teach you some topic related to matrices and their properties. Okay. So this topic is basically based on IIT-JAM students, GATE student, CSIR-NET student, and all academic student. Okay, so academic student like B.Sc and M.Sc student. Okay, so today I am going to teach you matrices and their properties. So first of all, I am show you some introduction and introduction and type of matrices. These are my outlines. So first is our introduction to matrices, then we are proceed on type of matrices, then matrix algebra and determinant and inverse and rank of matrices, system of linear equation, and one of the most important topic which is not optional, it is very important. This is eigenvalues and eigenvector and some IIT-JAM PYQ and some conclusion. Okay, now we proceed my lecture. This is some error because all content uh, I paste it by LaTeX code. So not a problem. I'm show you some uh, contact like this. Okay. So first of all you, I am say about matrices, and matrices is nothing but these are the definition of matrices. Okay, and matrices is say about important is why because these are the convenient way of storing information in the form of m horizontal rows and n vertical columns. So it can be represented as like this: a equal to in a square bracket aij and dimension is m cross n, where these m cross n are represented as dimension which is from a row and column only. So these are the definition because uh, these matrices were applicable or used in storing information, storing information, information. Okay, in form of m horizontal, which is basically represent at a column and n is our row. Okay, so these are the horizontal, which is rows, and n is our column, vertical column. Okay, so these are the matrices, only some definition. Now we are proceed on type of matrices. Type of matrices. In type of matrices, matrix will be represented in like this. First one is a rectangular matrix, and then is a square matrix. Many matrices like some study in a special type and some study in a simple type. Okay, so type of matrices like this. First one is our row matrix. Second is our column matrix. Third is our rectangular matrix. Fourth is our square matrix. Fifth is our triangular matrix. Six is our diagonal matrix. And seven is scalar matrix. It is our identity matrix. Nine is our idempotent matrix. 10 is our nilpotent matrix. 11 is our involuntary matrix. 12 is our symmetric matrix. Okay. 13 is our skew symmetric matrix. 14 is our orthogonal matrix. 15 is our unitary matrix. 16 our companion matrix. Okay. So these are the matrices which we study one by one. Okay. Now come to the first point is our row matrix. And in lower class we study some like approx identity matrix, or now in advanced class we study about some idempotent matrix, nilpotent matrix, involuntary matrix, symmetric matrix, skew symmetric matrix. So for lower class we study only 8 point. Okay. In higher class we study all matrices. Now we are going to study one by one at wait a minute. Well, let's see class. Okay. So one by one we study these matrices. Okay. So first of all, I am say about some row matrix. Row matrix. Okay. So no row matrix is nothing but these are represented by A is equal to in bracket 1 2 3. Okay, these are the row matrix where dimension is 1 cross 3. Okay, so these are the 3 column and 1 row. Okay, and like this A B C D, these are the matrices. These are the dimension 180 type matrices. Okay, the second point, which is our matrix. Okay, column matrix. So column matrix is like this: 1 2 3. This is a 3 cross 1. Okay, and be represented as A B C D. It is also 4 cross 1. Okay, So these are representation of some matrices. These are raw matrices and column matrices. Now come to the 3 point. Some problem related to column matrices. Okay. So I am going to teach you some problem as an example. Okay. Now come to the problem. Problem is given like that. Let x comma y belongs to r ke power n. Okay. Be two non-zero vectors, and then what about its transpose? It means the multiple of these two matrices and y transpose. Okay. These are the actually transpose is represented like this, T and dash. So with representation are both representatives are satisfied for this. So now actually a standard representation is XY transpose. So transpose is nothing but like this. If I have some row matrices, this is a dimension 1 cross 3. Now it like in transpose 1, 2 or 3. Okay. It interchanges the operations. These are the raw matrices, which is actually converted into column matrices, and their dimension is 3 cross 1. Okay, so these are the representation of matrices in transpose. Okay, so now come to the problem, and what xty. Okay, these are the problem. Now come to the solution of this problem. So solution like that. Let x is equal to, we represent some column matrices. So it is represented like this because there is nothing, any dimension is given. So we take example as a counter. So x equal to x1, x2 dot xn. Okay, these are the matrices. So these are the column matrices. Y, some element is y1, y2, and yn. These are the column matrices. So where, wait a minute, some call are coming. So where x, we represent some action in a form of xi, and yn represented as yj. These are the representation of row and column, because all element entities are in form, so we change in xi and yj. Okay, so for all, one is nothing but it is less or equal to y. Okay, and j is represented is less than equal to n. Okay, and xi which is not equal to 0, and yj which is also not equal to 0. So these are the notation for these two matrices, and these are outcomes for this. Okay, so these are the outcomes for some I and j. So my first purpose is that when we represent like that this, so I represent in xy transpose or x transpose y. So come to the this point. Okay, so now when we multiply these two matrices, which is x and y transpose, so it is represented like this, because all entities in x which is same. Okay, x to up to xn. Okay, these are the matrices which is column matrices, and y is represented as a form of transpose. So these column matrices is interchanged into row form. So matrices y1, y2 up to dot dot. These are the because we convert y into y transpose. These are the conversion of change into y equal to y transpose. Okay. These are the representation of transpose of the matrices. Now come to the point when we multiply both. Okay, so you know the multiplication of the matrices because these are the column matrices and these are the row matrices. So multiply one by one. Okay, so x1 and y1 and then x1 and y2. Okay, and these are the goes from x1 to yn. Okay, now come multiply with the second element. So these are the x1 y1 and x2 y2. These are also goes through x2 and y1. Okay, and now come to the last point which is xn. Okay, so xn multiply in y1 and then xn multiply with y2. These are also goes in xn yn form. So these are the matrices. When we multiply two matrices, it comes like that. Okay. Now these are the basically order change. Order change, it means the order of the matrices is n. The order of the matrix x y transpose in n. Okay. So since x y are non-zero and each xi is gets multiplied with each y's for this condition. Okay, for these conditions, so matrix is therefore imply matrix x transpose has at least one non-zero entry. So as seen above, all rows in column are a scalar multiple of each other. Therefore imply only one rows column is linearly independent because the terms linearly independence and linearly dependence comes from the vectors. So when all scalars multiples are equal to 0, then we say that the vector is linearly independent when only one or at least one, okay, at least one AI is not equal to 0. So then we say that it is a linearly dependent. So these are the linearly independent and rest are linearly dependent. So now take X transpose Y. Okay, these are the relation of by using some vectors problem in that question. Okay, now come to the next transpose, which is basically x transpose y. And x transpose is nothing but when we take our x is what x is like entities is x1 x2 dot xn, and their transpose is interchanged into row form. So x1 x2 dot xn, these are the row form, and we have y, and y is our column matrices. So y is our column matrices and their entities is yn. So we multiply both x transpose y, which is equal to x1 comma x2 dot xn, and y is our column matrices. So y1 y2 and yn. Now multiply one by one. So when we multiply these terms, it comes into row form. So these are the row form x1 y1. Okay, some adding x2 y2 plus dot x and yn. Okay, these are the matrices which can be zero or non-zero for non-zero vectors x and y. Okay, these are the matrices. Now these are the problem related to some problem which is basically asked in our exam. Okay, so basically understand about the transpose or anything else. We first of all you study in your basic manner. Okay, now come to the next point, which is our rectangular matrix. So now come to our next point, which is our rectangular matrix. So what is rectangular matrix? Rectangular matrix is order m cross. If any matrices is given in order of m cross n, okay, in the form of rectangle, form of rectangle in a form of rectangle such that m which is not equal to n, okay, is called rectangular matrix. Some comment are there because I forget. Excellent, sir. Okay, thank you. Because I forget my charger in campus lab. Currently, I am joined B.Sc campus Hyderabad for a project work. So now I am come to the point which is a rectangular matrix. So these are the basically order of m cross n in a form of rectangle such that m not equal to n in is a rectangular matrix. So now I take some example which is basically about a rectangular matrix. So take some example like 3 cross 3 matrices. So 2, 3, 4, -1, 6 and 5. Actually these are 4 cross 3 matrices. Okay. 10, 7, -19 and 4, -3 and -6. These are 4 cross 3 matrix is a rectangular matrix. Okay. Matrix of order 4 cross 3. Okay. So these are the example of rectangular matrix where m not equal to n. Okay. Because you see in here both dimensions are different and row and column are different. So these are the 3 column and only 4 row. This represented as row, you know, this is row and this is row, and it is also row, and these are the column and column and column. Okay. So basically these are the 4 cross 3 matrices which is an example of rectangular matrices of order 4 cross 3 because in rectangular matrices I am not equal to n. First you understood this. Now come to the next point which is our square matrix. So a square matrix is nothing but it is the same row and column. Okay. So a matrix with same number of rows and column. Same number of rows and column which is called as matrix, which is basically used in our orthogonal matrix because these matrices are very important for us. Okay. And example like that, a square matrix A is equal to 1, 2, 3, 4. These are the 2 cross 2 matrix is a square matrix of order 2. Okay. Now come to the next point, some problem related to a square matrix. Let me see. And then, yes, I have a problem related to a square matrix. So first of all, some problem related to a square matrix, we start as a trivial or non-trivial concepts. So number of non-trivial entries in a square matrix and some trivial entries in a square matrix. So I have example for non-trivial entries in a real square matrix. So problem related to basically problem is what? Problem is find the number of non-trivial entries in a real square matrix of order n over r. R is basically represented as real number. So come to the solution for this problem. Okay. Now solution is like that. Take some non-trivial entries. So take a matrix like order n cross n because it is a square matrix. So n cross n order where entries aij belongs to r. Okay. And for all I comma j and entries like that a11 a12 dot a1n. Okay. And next one is a12 sorry a21 wait a minute a21 a22 a2n. Okay. This goes on a n1 a n2 okay and a n n. This is the square matrix, which is basically entries are non-trivial. So these are the real square matrix for order n over r. This is the example basically for this problem. Okay. So number of non-trivial is what? So number of non-trivial entries is in a is equal to n square. Okay. Now come to the next problem, which is also related to complex square matrix of order n. Non-trivial entries in a form of a complex matrix of order n over r. Okay. So next problem is related to a complex number because these two real number and complex number, which is basically used in our vector space. We study in a field and a scalar multiple field and in field use a set of real number and set of complex number. So come to the problem, and the problem is what related to complex square matrix of order n. So problem is find the number of non-trivial entries in a complex square matrix. Actually, I forget my chargers in our lab, so I am not take class more. So these are my last topic for this today class, and in next day I will make a slide for class. Okay, so these are my last problem for related to square matrix and entries in like complex square matrix type. So complex matrix of or n. So basically, I'm going to represent these are these matrix. Okay. So now come to the next slide, which is our solution for this problem. And solution is let some matrix in form of complex. So it is a very big entry which will you show in your screen and take some entries like aij comma bji bij belongs to r for all I comma j. Okay. So how we represent these square matrix in a form of complex. So you know the complex real part and imaginary part including in complex number. So now take a matrix like that: A11 plus iota B11. Okay, these are the entries for complex number. So next point is 1 or 2 plus iota B12. This also goes on A1, A1n plus iota B1n. Okay, these are the entries. Basically, I raise this slide. Okay, iota B1n, and next part is A21 plus iota B21 also, and take 2 plus iota B22, and this goes on A2n plus iota B2n. Okay, these are the entries for complex number, and it will go on an1 plus iota bn2. Okay, wait a minute, I make a mistake here because it is an entries only related to one. Okay, so n1 plus iota b n1. Okay, wait a minute, I am very tired now, so my mind is stuck. These are iota b n1. Okay, and next entries is a n2 plus iota b n2, and this is also goes on. Last part is a n n plus iota b n n. These are also the representation of n cross n matrices, where a ij comma b ij belongs to R, and for all I comma j. Okay, so these are the entries which is basically used by order complex number type. Okay, now check the number of non-trivial non-trivial entries a equal to 2n square. Okay, these are the entries. So this is my last problem. Now next is our principal diagonal triangular matrices, upper triangular, lower triangular, or diagonal matrices. We actually study in our next lecture. Okay, because I forget my charger and I am connected my mobile hotspot in our computer. So our next class is tomorrow at same time. Okay, so thanks for watching these videos. Okay, okay, actually I am in my lecture. Sorry for that.